So how do we take 80 feet per second and get miles per hour?
Multiplied by the conversion fraction, which is going to be seconds to hours over feet to mile, So 3,600 over 5 to 8.
So the process, if you want to change seconds to hours, you need to set it up, as Daniel said, to make sure the seconds cancel out. So 3,600 seconds in an hour, or 60 seconds to a minute, 60 minutes to an hour. And then how many feet in a mile, right? We call this factor labeling. In my day in high school, you guys call it dimensional analysis or something. It's just converting units. And personally, that's how I see implicit differentiation. The second one, the derivative with respect to t. How I do that? Okay.
Well, so first I did dy over dx, and I got the 5 cosine of 5x. And then you can multiply both sides by dx over dt. And so the left side becomes dy dt. And then we're given dx dt on the left, so we can plug that in.
Okay. So, and again, I see it just as converting the units.
Do you need to do the step where you multiply both sides by dy over dt, or dx over dt, or can you just say dy over dt equals 5 cosine 5x times dx over dt?
Okay, so that's the point of, so the way Sam saw it was, I'm going to do the normal thing, dy dx, and then I'm going to do dx dt. I had feet per second, I wanted feet per hour. You could also say from the get-go, I'm going to do the derivative of y with respect to t, which is not a variable in this problem at all. So now I need to do the derivative of the other guy with respect to t, means chain rule of this. So totally, you could just jump straight to the end. You get the same answer, and there's relatively no difference in the work that you're going to show. However it makes sense in your mind, feel free, but don't forget to do it. And again, this is why I have been writing all year, no y primes, dy dt, dy dx, what am I doing the derivative with respect to, so that I don't forget. Cool? Questions? Yep.
Wait, since it gives you dx dt, shouldn't you plug in 3?
And now plugging in 3. So it's going to be 15 cosine 5x. Yep. Okay. Everyone did take the test? Okay. Do you guys remember how to do this from pre-calc? You do?
If secant theta is 5 over 4, then cosine theta is 4 over 5. And
Yeah?
using the Pythagorean theorem, you can find the third side, which is 4.
So, okay, so Andy says, and I should have put this extra point, hey, the angle's in quadrant 1. Andy says, so we draw a triangle out, and I don't know theta, I'm not allowed to use a calculator, but secant of theta is 5 over 4, so hypotenuse over adjacent is 4, and Milo says the third side is a 3. So, still not even knowing the angle, Jeremy, what is tangent of theta? Looking at the triangle we've drawn.
Oh, I don't know.
What is tangent? Opposite, adjacent, hypotenuse, whatever way.
So it would be 3 over 4.
Yeah, okay. I know you did pre-cal in a different place, so we do this here. So, as I said, I graded the front of one version of the test. This question was on there, and only one person did it the shortcut way, but they had already tried to go the long way and couldn't figure it out the long way and went back this way. So you guys are very good at your trig identities. However, not good at looking ahead of what you needed to do. What's the derivative of sine? Cosine, really fast. You guys wrote so much. And then you got confused and you scratched it out and then you erased things and like ripping through the paper. Oh my goodness. This falls into the category of divide and conquer. Like, look ahead before you go too far. Like, oh my goodness, you guys spent so much time on this. And I was like, hey, like half of the people might miss this, but you know, the other half of you, it'll be like real, nope, all of you, all of you. All of you. Again, I've only graded half, maybe the other version. How many of you did the short way? Ooh, 2. Okay, you must have the other version then. Okay, good. Oh well. So, today we're doing derivatives of trig functions, and to do that, I just need you guys to remember some stuff. When a function fails the horizontal line test, we need to restrict it so we can do an inverse. Sine inverse is restricted here, a little viewfinder window to get all of the y values top to bottom. So arc sine, do you guys know? Arc sine x is the same thing as sine inverse x. Yeah? Like, what is, sine inverse of a half? Pi over 6. So that's asking what angle makes sine 1/2. There is exactly one answer that is correct. The calculator will always give you pi over 6. There are whole bunches of places that sine's a half. The calculator will only ever give you that first one. It's not going to tell you 5 pi over 6. It's not going to tell you 13 pi over 6. It's always just going to say pi over 6. That's what that restricted inverse thing is. Cosine is restricted. Cosine inverse, 0 to pi. And tangent, AP loves tan inverse, absolutely. You best learn to love it as well. Tan inverse looks like this. It has 2 naturally occurring horizontal asymptotes. They love this. We can integrate from a negative infinity to infinity and get an answer. It's crazy. Yep.
I thought in pre-calc, I might be remembering wrong, but they said something about the capital of arc sine, like if it's lowercase, it means something else.
Okay. This capital letter means restricted.
Okay.
Like, the way I say it is, the capital letter is the calculator answer.
Okay.
Calculator only gives you one. Which one? The one that fits inside this little viewfinder. So just checking. Arc sine negative a half. Felipe is looking up at the ceiling tiles for the answer. What is it?
Negative pi over 6.
Yes, it is. Across from pi over 3 is root 3. 1, 2. So whereas opposite over hypotenuse, 1/2 at pi over 6. sine is restricted to one of these two quadrants, it's negative pi over 6. For those of you that said 11 pi over 6, my analogy is you're the ones that drove from Bethesda through Virginia to get to Silver Spring. You went the long way around the Beltway. Don't do that. There's a part called the mixing bowl you gotta go through, and there's a drawbridge, and sometimes it's stuck open. Ugh, Virginia. Who would put a drawbridge on, oh my goodness.
Virginia.
Yeah. Been stuck with the bridge yeah, 3 hours late to work, that went well. Okay. Arc cosine negative root 3 over 2. Where's root 3 adjacent? 5 pi over 6, okay. Negative cosine things comes out of quadrant 2. Arctan negative 1, negative pi over 4. Okay, cool. Yes. All right, so I'm gonna prove these guys to you. You don't need to be able to do the proof. But I want you to know why it works. And first off, let's look at this. Okay, I have a function that's differentiable over an interval. The derivative is never 0. Then the inverse is also differentiable over that whole thing. Can someone draw this on the board for me? An example of a function that dy dx is never 0 on an interval. So let's see. Here's my interval a to b. Can anyone draw a function that Lily? Cool. Because I was drawing crazy things first period, they're like, that sucks. So, I mean, could it just be anything?
Oh, sorry, that's
Hang on.
sorry.
Welcome to the board. Okay, that's an example. Can someone draw a different one? I mean, that's totally valid. Different one? Daniel? And if you want to use the little pen, you got to use the butt of the pen because we don't write with the tip of the pen because that makes sense. Okay.
Something weird.
Is that one valid? It's a little sketch in places, but it's questionable.
You could make an argument.
I could make an argument. Feeling pretty argumentative today, actually, so. A lot of parent emails. It's been fun. What about that one? No. Okay, so the point of the restriction of if the function never hits 0, what happens when it hits 0?
Changes direction.
It could turn down on itself. So to have an inverse, it needs to pass the horizontal line test. So like that trig function, sine or cosine, whichever one, fails the horizontal line test all over the place. If we say the derivative can't ever be 0, that's saying it can never turn around on itself. Therefore, it will have an inverse that is also differentiable. I used to just blow past this, but AP has been wily in how they ask some questions. So it's a wrinkle of a detail you might need to acknowledge. And there is at least one question on the homework tonight that needs this concept. So, all right, here we are to today. You don't need to write this. It is me showing you where stuff comes from so that you are inspired to memorize these, but not necessarily have to do them yourself. Okay, arc sine. I don't know how to do the derivative of arc sine. So how do I undo arc sine? What's the sine? Okay. So I am going to do sine of both sides. What is sine of arc sine of x? X, okay. Andy, what's the derivative of sine?
Cosine.
Thank you. Leave this stuff inside alone, but then times the derivative of stuff. Felipe, what is the derivative of stuff?
dy over dx.
dy dx, okay. You get the hard one? What's the derivative of x?
1.
Thank you. Okay, multiplying by secant y on both sides or dividing by cosine. There's my answer. Problem is, I want things in terms of y, that's crap. So, that last warm-up question that Andy was like, we're gonna draw out a triangle. Sine of y, there's my angle y, don't know what it is, but it's right there, is x. How do I label the sticks on the triangle?
Opposite over hypotenuse.
Opposite over hypotenuse, so opposite is x. What do I label hypotenuse? 1. Okay, Pythagorean theorem. Gross. Okay. Secant y, Da Vinci?
It's just the 1 over root 1 minus x squared.
So that's your derivative of sine inverse. They're writing it with u in it, which is chain rule. And they're saying the thing that goes in has to be less than 1. Well, what's sine inverse of 3? It can't be 3. Okay. So, and sine inverse of 1, that's going to violate the differentiability part. Like, at 1, that was where the horizontal tangent happened, and that was a problem. Also, if I plug 1 in there, I'm dividing by 0, so that's kicked out. Okay. Arc cosine, yes,
Wait, does that say times du dx?
yes.
Wait.
Chain rule. I'll show you in a
Okay,
second.
right, because like, that wasn't the first I was confused.
Right. Okay. Here's the pretty thing about these. The ones that begin with C. Sine was that, well, cosine is contrary, so it's negative, whatever sine's derivative was. Sine inverse is derivative.
You wrote x and u.
I know. Oh, that, okay. Thank you. So, trying the pattern with this.
Ms. Pascal?
Yeah.
Is that where the du dx comes from, because we need to do the x side?
Yeah.
Okay.
Paolo, what do I get? The pattern is 1 over the square root of 1 minus stuff squared times the derivative of stuff. So what do I get? 1 over,
What? Sorry.
okay, I want to do the derivative of this.
Yeah.
The pattern matches up pretty nicely. It's 1 over the square root of 1 minus stuff squared. What is stuff in this case?
16x
Squared.
squared. Wow.
Times the derivative of stuff.
16x.
Sorry. So 16x up top. And that's what you were telling me. I thought you were telling me that was 16x. My bad. Yeah? Kinda? Ready for tangent? It's a party. Woohoo! Okay. Same process. I don't know how to do the derivative of arctan, so I'm gonna do the inverse function. The derivative of tangent is secant squared. The derivative of x is 1, and I forgot implicit. Got to do the derivative of y with respect to x. Get rid of secant squared by multiplying by cosine squared. It's not an x, it's a y. Jeremy, how am I going to label my triangle if tangent of y is x? Tangent is opposite, adjacent, hypotenuse, whatever what.
The opposite would be x, and the adjacent would be 1.
And Pythagorean theorem, 1 squared plus x squared under the square root. So Annika, what is cosine? Reading cosine off the triangle. That's cosine, but I wanted it squared. So Francesca, what do I get when I do that squared? Oh, that wasn't so bad at all. Derivative of tangent, right there. And I forgot we had a day off tomorrow. Your test is probably not Wednesday, but I'm not gonna change it. It's gonna like stay on the board as this to scare you for a little bit, till I can like really verify that it's gonna be really Thursday, but. Yeah. Okay, anyone got a guess what, the derivative of cotangent inverse might be? Negative that stuff. So I'll try and apply a pattern. Constantine, feel free. Okay, 1 over 1 plus stuff squared, so stuff is x squared squared is x to the 4th, times the derivative of stuff, which is 2x, and then it was cotangent, so the negative's there. Good? Okay. So, all right. Next is our friendly secant. Said with sarcasm. Secant just sucks. All right, derivative of secant is secant, puts itself in its own derivative and brings a friend, and then we gotta do implicit. All right. Multiplying by cosine cotangent, that neutralizes these guys on that side. All right. How do I label as sticks? Ms. Milo, how do I label the triangle if secant of y is x? Opposite adjacent hypotenuse, who do we know?
Adjacent and hypotenuse.
Mm-hmm. Is adjacent x or is adjacent 1?
Adjacent is 1.
Okay. Pythagorean theorem. Gross. Yuck. All right. Alex, what is cosine of y, reading it off of there?
X.
Cosine, not secant.
Wait, cosine of y.
Cosine of y.
Oh, 1 over x.
Thank you. Francesca, what is cotangent of y? Okay, secant sucks. All right, and on all of these, I've had a graph of the inverse up in the top corner. Hasn't been relevant till now. Looking at secant, arc secant, what is the slope? Positive or negative, or is there a mix and match? It's always positive. Always positive. As I go left to right, it's always positive. Okay, it's getting less and less, but it's still positive. All right, secant sucks. You gotta do the jail bars like this. Jail bars. And because the math community argues whether this is really the domain, actually proper range for secant inverse, AP will never ask about secant inverse. There is a problem on the homework that you need to pattern. It is not on the AP exam. Because when you get too mathy, they argue over dumb stuff. So, it only took me 15 years to find that part out. Cool. Okay, so there's all the patterns. Which, if you know these three, you know their co-counterparts. And I just told you you don't need to know secant. They have a story to maybe help you remember some of them. Okay. What trig function did you learn first? Just want one, so
Sine.
you would pick sine, right? Okay. Sine begins with S, so there's a square root, and a subtract, and you learn sine first, so the one goes up front. Yeah? Yeah? Okay. Secant begins with S, so there's a squared, a subtract, and a square root, and you did not learn secant first. The one goes up back there, and it sucks. So it's got the little jail bar things. I'm not gonna ask you anyway. Tangent does not begin with S. Okay, there's still a squared, you figure that out. But the T in tangent looks like the plus sign, okay? Sam, come up with something better. It's always my throwdown, like if you think that's cheesy or stupid or whatever, make up your own. No one has. There's my story. Secant begins with S. Sine begins with S. Learn sine first, so the one's up front. I don't know, whenever I see these, that's what goes through my head. It's 1 minus u squared under the square root. Okay. So, if you guys look at the assignment sheet, there's usually, I need a day and a half to get through things. I would like you guys to be able to do all of the homework assignment that's out there, should you not be in synagogue tomorrow. But I at least want to get the rest of this out. We also need to be able to do derivatives of just regular old inverses. And I don't want to do this specifically, but what do you guys know about inverses? Like, oh, come on. What do you know is on F inverse? If you know the function has the coordinate a, b, what coordinate do you know in the inverse? Coordinate. Oh, okay, I didn't hear the b. Inverse means like putting one, get out the other, yeah? Okay, so for me, we're doing derivatives of these. I don't know how to write F inverse prime, so I'm gonna use as a shortcut in my next couple examples. G of x is my inverse, okay? That's my, I'm defining it here. Okay. There's my coordinate AB, okay? And inverses fold over y equals x, right? So what coordinate's going to be on the inverse? BA. And this rise over run, so this slope at A, rise over run, is M, becomes run over rise. Sorry, it's connecting too many things, but so the inverse slope at, I can't say x anymore because this guy's x is that guy's y. So the inverse's slope at its counterpart point is just the reciprocal, not inverse reciprocal, that's perpendicular. And this picture isn't great either, but this is what's going on. And I want you to try one example where you do know what the graph looks like. So, And if you don't know the inverse of x squared, find it by trading x and y and solving for y.
Just take the positive.
Okay, Ben, if x squared is our function, what's the inverse function? How do you undo squared? Okay. Lily, what's the derivative of x squared?
2x.
Paolo, what is the derivative of square root of x?
1 over x squared. I mean, 1 over root x.
Okay. Jeremy, what is, not f of 4, sorry. F of 2.
4.
Alex, what is f prime of 2?
4.
Okay. And for the inverse, I'm gonna take the y value here. So the inverse, sorry. What is just g of 4?
2.
2. Alana, what is g prime at 4? 1 over 4. I mean, we're just plugging it in. So these are just, like, I actually calculated the numbers. I cracked things out. Here's the relationship of the coordinates. This was AB. This is BA. F prime at A was M. G prime at B is 1 over N. So this rise, whoo, I didn't know that moved. This rise over run became run over rise. Just reciprocals, not negative reciprocals. And first period asked something like, oh, so we can just blah, blah, blah. Like, kinda not really. Because they were like, can I just always crane through with the function? What if I don't tell you about the function? The good news is this is rarely on the AP exam. The bad news, you're about due. It's gonna be on it for your year. I hate statistics, but I'm good at playing the game. Anyone got a stab at the answer? There's not a lot of choices. Yeah, 1/6. Okay. My process, and seriously, I need to do this because I do concept dyslexia a lot. If this guy's got AB, that guy's got BA. The slope of this guy, they told me is 6. So the slope of that guy at his counterpart, sorry, I'm putting in the wrong coordinate, aren't I? 3, 5. So the slope of that guy's counterpart point, yes, 1/6. So your homework is out of the textbook, but Delta Math does a lot of this inverse stuff, and I will send out probably on Friday or something before your test, whenever that is next week, an optional thing to do practice on Delta Math because it's weird, and your book has like 3 questions about it. Period. Anyway, all good?